All right. Thank you very much, guys, for joining in today. Yesterday we had our first session, and for those of you who are in there, my name is Angoda Brian Nyanga. I'm a software engineer by profession, and also a Flutter developer. Yes. So yesterday we went through certain schedules like introduction. We introduced ourselves for those who are there, and then we got familiar with our common goals and what we want to achieve from this course. And we later on had an introductory Flutter session where we talked about Flutter, its benefits, and cross-platform app development in general. And then we also ran through how to install Flutter on Windows operating systems or Windows machines. And also we shared some links on how to download the resources necessary, the softwares necessary to make sure Flutter can run. Yeah. So today we are going to be going through an introductory Dart programming course. Yeah. So Dart is a programming language that powers Flutter. And so we are going to go through it a bit. So for those of you who are not so familiar with programming, we are going to try to we're going to try to make it as simple as possible so that we can all grasp these concepts. The good thing are these resources are always going to be available for you. The links to the sample code that I'm going to be showing here are already provided. So you can click those links and be able to see the code. So the code, some of the code is commented so that you can only run the one you want. So when you want to run some code, you uncomment it, then you run it, like we're going to show shortly. Yeah. So today, basically, our goal is to first look at these fundamentals of Dart programming. Okay. First, we're going to look at the structure of a Dart program, like the very lean structure of a Dart program without any other complex stuff added to it. Then we're going to look at variables, what they are and why we use them in Dart. How do we use them in Dart? Then we shall look at operators. Okay, how do we use operators and what are they? Then we shall look at something called loops. What are loops in programming? Okay, then we shall look at decision making. How do we write code that can be able to make decisions? Okay, bring a bit of intelligence into our code. And then we shall look at numbers. Which type of numbers do we have in Dart? Okay, we shall look at numbers and some of the things we can do with them. And then we shall go ahead and look at strings. Okay, so strings are just the opposite of numbers here. If I can put it simply, strings are like the opposite of numbers. So we shall also look at what we can do with strings, how we can transform them and manipulate them in some way. And then lastly, we shall look at booleans. So booleans are basically values that can have two states, either true or false. We shall look at also booleans in the course. So that being said, let me start by sharing my screen and showing you the repo. So this is going to be the repository. So if you have this link, okay, there is this link that was being shared in the WhatsApp group. You can click it, and then when you click it, you'll be able to see the code samples that we're going to be using today. Okay, you can see that this is the first program, which is going to show us the basic structure of a Dart program. Then the one for variables, all the code samples for variables are here. So if you don't see me typing, just know you already have the code and you can copy and paste it somewhere. Okay, and then we also have operators, all these other files that we talked about in the outline for today. Yeah, and then like I mentioned yesterday, if you're not able to install the Flutter SDK, okay, if you're not able to install Flutter SDK, today we are going to have an alternative. You're going to go and use a Dartpad, okay, Dartpad to run your code. Yeah. So before we even start with that, I'll have to show you how to open this Dartpad. If you're using a computer, you'll just search for this Dartpad. You search for Dartpad on Google. So when you search for it, the URL is just dartpad.dev. Okay, it's dartpad.dev. So this URL can be used to access a runtime that can be able to run for your Dart code as you're following along this course. So this will help you see the output of the code without just looking at my screen. Okay. Yeah, so I'll be able to explain all the code, most of the code, so that we can these concepts and why do we actually use them in programming. Yeah, so that being said, let me go back to the slides. So first things first, what is the structure of a DAT program? Yeah, so basically in a DAT program, we have what they call a main function. So it's a predefined function in DAT. Okay, this is inbuilt. So all you have to do is declare that main, and then you do something with it. So basically, a function is something that holds a group of statements. Statements meaning code. Okay, so for this one, you can see a statement string welcome is equals to welcome to this. So in this code, you can see that first statement is a statement where we're declaring a variable called welcome, which is a string, and it is holding certain data. And the data is just a message, welcome to Risto University, Flutter course, okay? And then we have the second statement, which is a print statement, okay? So here we say this method acts as the entry point to the application. So every DAT program must have only one main function. Oh, there's only one main function in one DAT program, ideally. Okay, so you can't have a DAT file and you have multiple main programs that are uncommented. No, there'll always only be one main program, main function, okay? That is uncommented, and it's the one that runs. It's where your application starts running from, okay? Yeah, so a DAT script needs the main method for execution. Without this, your code can't run. Yeah, so print also is a predefined function. It prints the specified string or value to the standard output. The standard output being basically your terminal. Yeah, so it helps print these values to your terminal. For example, if we go back to my DATpad, this is the same code. Okay, so when I run it, it will take some short time. Yes, then it prints the output that welcome to Risto University Flutter course. Okay, so this is like the terminal. Okay, the print function helps us print some output, and it's very good when we're testing our application, testing the output of our logic and all that, and it's what we're going to be using for displaying data throughout. Yeah, so basically this is the basic structure of a DAT program. Just know that every DAT program you write must have a main function. One main function there. Yeah, so when we look at variables, is our next thing. What are variables? Basically, in programming, variables are a way to store data, okay? They're a way to store data. But scientifically, we can say that they are named memory locations in computers for storing data, okay? There are also symbolic means that represent stored data values. So the reasons why we have variables is because we want to store data of certain sort, okay? So when you talk about data, we can mean files, audios, which are also files, images are files, then we have text, okay? Like a phone number, that is data, names, that's data, okay? Sentences, articles, news posts, that is all data. So we store that data in variables, okay? So variables are things that work during when a program is actually running, okay? So the data that you store inside a hard disk, that you don't call that data stored in a variable. So this one majorly acts in memory. So that's why we say it's a named memory location in a computer for storing data. Yeah, so variables are going to be a very big part of this programming journey. Yeah, so the value of a variable can be unassigned, okay? We can declare a variable, but we don't assign anything, so it can be unassigned. It can also be a string, which can be an alphanumeric character, string, a number, or a dynamic array. Alphanumeric meaning that string can have both letters and numbers and certain special characters. Then a number, basically, that can be an integer or a floating point number. An integer is basically a whole number, then a floating point number is a number with a decimal place. Or it can be here a dynamic array, okay? So dynamic arrays are arrays that can hold data of any type, in this case. So a number, which can be a fixed point, an integer or floating point. Yeah, we already mentioned that a variable can also hold a number, integer or floating point. Then a null value. Null simply means that there is actually nothing we have stored in that variable. Okay, so it's null. It has no type. Then there's a dimensioned array, that is vector or matrix. By dimensioned array, meaning you can have arrays inside arrays. So an array in programming is basically a variable that is used to store a list of certain data. Okay, and usually it stores data of only one data type. Okay, yes, so we can have a list of names stored in one variable, which is called an array. So an array is a special type of variable that can store like a list of items. Okay, yeah, then we can have a subroutine name. See? So subroutines are kind of like methods. Okay, so these methods also is a way in programming you can have methods that are assigned to variables, and that's why we call them variables here. Then a file, like we said, a file can be like an image. Okay, audio files, videos, those are also variables. Okay, because they are first stored in memory when you're using it. Essentially, they are stored in memory when you're using it. Yeah. Then a select list. Okay, it's a list of other lists, essentially, if I'm to simplify it. Yeah, so these are all types of variables that you may find in programming. But then we're going to look at variables in that. Okay, so in that we can have strings. For example, a string with an identifier called name. So name is what they call an identifier. Then its type is it's a string. So this is a variable. We have the identifier and the type, and then its value. So here we have declared a variable called name and assigned it a value restore. So that is a string. As you can see, a string can have both letters and numbers. So I can say list restore 404 or something like that. And then we have age. Age is here in this context, it's an integer. So integers, like we said, are those which have whole numbers, no decimal places. So age 2. Yeah. Then double. A double is a floating point variable sort of type, meaning it holds it holds numbers with 2 decimal places. Okay. Yeah. So there is 42.9. There's a decimal place there. So a variable called double can never be assigned to an integer, and an integer can also not be assigned to what? A double. That's why we have 2 types. You have to choose which one you want to actually use. And then there is Boolean. Bool is married equals to false. Bool has 2 values, either true or false. So in this case, we're saying false. So we declare a variable called is married, and then we say it's a Boolean, and we assign it a value false. Okay, and then we have list. But a list can be of a certain type. For example, in that you actually mentioned, most times you have to mention the kind of that you want to store in your list. Yeah, so a list of strings. Okay, that means it's going to store. Remember, we said strings are values which can have both as a letter. That's why here you're seeing S1, S2, S3, S4, S5, and S6. Okay? That is a string. Those are strings. This is an array. In simple terms, here they call it not an array. So it is, okay, you can hold more than variable. So instead of just saying S4 variable, we just create a list of all the classes inside there. So this is a list of classes. These classes are strings. So it's a variable in that. And we shall build a lot of lists in our program. And what they call maps. A map is a it's a type of variable that allows you to name kind of data that you're storing and the value. So for example, here we have a map type string in. It's going to be identified string here. Keys are going to be here. We have O level, and we are saying number of levels, and the number of classes in this level are 2, and then a level. The number of classes in this level are 4. Okay. Then we have dynamic. So dynamic simply for when programming that really don't want to make the type of the variable fixed. You make it dynamic. Okay. So here we say dynamic here is equals to 2024. So I can also make this a string. So dynamic is a type in that enables you to just put any value in this variable. Yeah. So we use it a lot also sometimes when we're not sure what kind of data. For example, when you data from an internet, and sometimes let's say empty values are coming back. It's sometimes safe to use dynamic so that your app doesn't crash. Then we have keywords. It's also it's used to assign to create variables, but then the value of the data is the one that determines the type of variable it is. So month equals July. This is a string data type. Okay, so it's the data that the type of variable that this is, but it's open. When you say it's open, and it can be changed at any time. This one can change at any time. And then we have const. So the keyword used for declaring variables that can never change. So when I say const day equals to Tuesday, I am supposed to check of variable. Okay? You declare constant. Okay, you any variable is on it, and you want it constant to change any other in the program. But then finally to make sure you don't redeclare or declare one of this. By declaration, it means you don't suppose to put a keyword in front of it. Yeah. Yeah. So here a detailed explanation of that I used to declare constants. So preventing the values of a variable declared using the final const keywords. These keywords can be used in conjunction with the variables that type instead of the var keyword. So you can say final integer, then you put the name of the variable equals to, then some date it, okay? Yeah, so you can use it in conjunction with the data type. Yeah, then the const keyword is used to replace compile time constant. And variables are implicitly final, meaning you can't relate later on as opposed to the others, okay? And the moment you say const, you better give it a value because later on you won't be able to. Yeah, so all variables to compute a compile time constant, and constants always will be determined at time. Okay. So here, basically programs that backcoding saying that variables must have values already. They should be no, don't let me guess it. Must be compile time. Yeah. So that throws exception if an attempt is made by variables declared with the final or const keyword. Okay. Yeah. So that is also a very serious thing. If you try to redeclare a variable that you are declared using the const keyword, that will be warning. But lucky for us, we have code editors that are enough to warn you even before you try to run the code. So for example, if you're using VS Code, it will warn you before you even try to run the code. Yeah. For that, look at operators. So the operators are special kinds of value. Okay. And every composed of something, for example, represent the defined operands will be processed to produce a value. If we look at 2 plus, then 2 and appearance, and the plus sign is the operator trying to find these values. Then the operator determine those values. So it is our operators in that there are types of operators actually. They are always grouped to make programming easy. They group them so another thing to use here compare certain values, exploration tasks. If you want to do mathematical operations, arithmetic operations, then the arbitrary operators which are rarely used. We are not really looking at it here. Then we have assignment operators, assign variables and all that. That's from certain areas. Operators are so that it subtracts the value of star. You look at that star, it multiplies. Okay, it's for multiplication. Yeah, so we don't have X in programming to be used for multiplication. We actually have that star sign. It's also found on our keyboards. It's star is used for multiplying numbers. Say 2 times 3. So you put star to put 2 star 3 to multiply something. Then we have the forward slash. The forward slash is used for, yeah, this is a forward slash. Yeah, this is for divide. And then a forward slash. So divide and integer result. So we get the integer result. So in program, percentage sign is used for modulus. Modulus is basically after what? Integer division. Yeah, that's modulus. Then there's increment. Increment simply means you're trying to add the value of a variable by 2. Plus plus. So plus plus increments a variable. Let's say if we had age equals to what? 20. So plus will add its value by 1. So 21. Yeah. Or minus will increase the value of the age, which was 20, to what? 19. So those are the operators that we have under what? Arithmetic operators. Then we have equality and relational operators. Yeah, so these are basically just to be able to compare values. So it's just basically simple math here, but we in programming they tend to group them like this so that we can jointly be able to identify the type of operator. For example, greater than. Let's say if A is equals to 3 and B is equals to 4, then you try to compare. Yeah, A is greater than B is false. What? But now for this case, if they are saying if you want A greater than B to be false, that means B here has to be greater than A. Okay? Yeah, so that is how we evaluate this. Then there's lesser than, then there's greater than or equal to. So this is also used a lot. Greater than or equal to. Sure, certain greater than or equal to something before you perform an operation, or less than or equal to some value for perform a certain what? Operation. For example, when you're building a loan app and someone's credit score is not greater than or equal to certain value, they can't give them a. So you have to, these are the factors that you know you're doing your program. They'll come in very handy. Believe me, it will be like something that you don't even have. Yeah, because and that. So equal relation. Example, this one, equality, compare. A equals to B. A, let's say B, let's say 4, this false. But then if A are 3, that is going to be what? So then there's the not equal. Okay. So if A is equals to B, then this operand will what give us a boolean true. So this one you would make sure it's true. So in practice, you find that equal signs, there's exclamation mark to equal signs, but have only one equal sign to it's like checking for checking. In our plan is here. So for arithmetic operators, for here, but I can always pick. Okay. So even you can always copy this. Then you take it to, let's say, your DAT pad or wherever you've installed your DAT. If you have it on the computer too, then you can remove the comments so that I'm able to run. Now I want to just show you an example of how to execute the code that is in the code samples. So it's all initially commented because I have multiple main functions inside the same file. But then essentially what you're supposed to do is you copy it, then you uncomment and try to run. Okay, so that's the whole point of those code samples. So whatever I'm going to be talking about in this lecture has examples. There's an example for everything I've mentioned. Okay, so here you see your addition, subtraction, multiplication, and how it's done. Okay, so if I have my variables up here, number 1 is 101 and it's an integer. Number 2 is to 2. And then I have one called what? Res. Res means result. But I've not what? I've not assigned any value to it. So it's just open. It's just waiting for results. So as we run the program, results are now given to it. So its value keeps changing with it every step that comes. Yeah. So yes, I've run my program in that part and you can see addition is this, subtraction. So addition is of those two numbers, 101 and 2. Plus 2 gives us what? 103. Then subtracting 101 minus 2 gives us 99. Okay. And then multiplication 101 times 2 gives us 202. Okay. So these code samples work. I made them personally, and they all work. So if you come to operators, you'll find that you have code samples from the start, arithmetic, then equality that we just looked at. Okay. And then we have for the type test operators, okay, we have all that code, okay? So feel free to copy and try to paste it and try to understand. So the more you run this code, the more you'll understand it, okay? On top of the explanation I'm giving you here. Yeah, so that was the equality one. This is true if the object is of the specific type. For example, let's say if something is an integer, you say if this is this, okay? So let's look at that kind of code, okay? So here, I can pick this code, yeah? Let me just run this here. At least it's good for me to sample this code and you see how it runs here. I know you have a copy, but allow me just sample it also. Yes, so if I try to run this, okay? You see, so it will tell me that what? N, the result is going to be true, okay? I'm trying to test this is keyword, okay? So I first declare int n, I say it's equals to 2. Then I print the value, okay, to the terminal. I say n is int. So if n wasn't an integer, let's say if it was a string, we would see a different value. For example, let me try to alter this. I comment this, and I say string n is equals to test. Then I try to run. I want to see what it's going to tell us. Okay. False. Then I try to run. I want to see what it's going to tell us. Okay, false. So n is not a what? It's not an integer. So it says false. So this is basically that those keyword, the is keyword is used to tell us the type of variable. Okay, the type of variable that is operators. So these operators are the ones I told you that we often don't overuse them, but it's very important also kind of understand how it works. If you want to get into other complex programming tasks, you can always use bitwise operators. So bitwise and for A and B. So in programming, this symbol is also called and. Okay, it's called and. Yeah, you're trying to measure two things. So you say and A and B. So returns a one in each bit position, for which the corresponding bits of both operands are ones. Okay. This is XOR. So returns a one in each bit position for which the corresponding bits of either, but not both operands are ones. So then this one not. This one negates or inverts. Okay, it inverts the bits of its operand. Okay. Remember, don't forget the keywords here. There's operand and operator. Okay. So the operand is in this case is A. So this is like the operator. Okay. It inverts the bits of its operand. Then this one is for shifting, the left shift. This shifts A in a binary representation. B here, then we say less than 32 bits to the left, shifting in zeros from the right. So this is low-level computing, and it's a bit complex. That's why I don't want to confuse us with that, too much of it. Yeah. And then there is the sign propagating right shift, okay, which is the opposite of this, which shifts the binary representation B less than 32 bits to the right, discarding bits shifted off. Yeah. So like I said, you will rarely use these in your Dart programs. But if need be, you can always dive deeper and try to use it, but you rarely use it in your programs. Then we have assignment operators. So this one is basically assigning values. For example, if you say var age is equals to 12, you're assigning. That equal sign is used to assign 12 to the variable age. Yeah, so it's an assignment operator. Okay, so simple assignment assigns values from the right side operand to the left side operand. For example, C is equals to A plus B. Okay, yeah. So you have to take care of those. You take note of those sides. Okay, it assigns value from the right side operand to the left side operand. So these ones on the right side are assigned to this one on the left side. That means the value of A plus B, the summation of A plus B is assigned to C. So C will hold the end result of the summation of understand? Yeah. Yes. So minus equals to. So minus equals to, if age was 10, then you say age minus equals to 2, meaning you're going to say age is equals to age minus 2. That's what it does. Then star equals to, this one means you're going to say, let's say age is equals to age times 2, if you had a 2 in front of it. So if it was 10, then age becomes 20. Yeah. Then slash equals to, meaning you're going to divide age slash equals to 2 is the same as age is equals to age divided by 2. Meaning if it was 10, it becomes 5. Yeah, so this is how these operators work. Then we have logical. So logical operators, believe it or not, are used Flutter app, sample authentication. We're going to see how you can say if we're going to try to play with some variables, making sure, let's say if the email is not valid and the password is less than, let's say, 8 characters, let's give this person an error that your email is not of the right type. You see, so this AND symbol, okay, it compares two values. It helps us run two expressions. So the operator returns true only if all the expressions specified return true. So all these expressions have to be true. So if A, for this case, A is greater than 10 and B is greater than 10. So both these values have to be greater than 10. So if either A or B is less than 10, then it's going to be false. Then we have OR. Okay, so this symbol also, you have to be, I think it's easily found on most keyboards. Is that, yeah, those long straight sticks, those two. So you can press it twice and that one gives us what? The OR. It means OR. So you're saying if this doesn't work out, let's try out this. Okay, so this one returns true if at least one of the expressions specified return true. Meaning, if at least A is above 10 or B is above 10, it will return true. But if both of them are also above 10, it still returns true. But if neither of these are above 10, then it will be false. Okay, and then we have not. So here we're making sure if A is not greater than 10. Okay, if A is not greater than 10, this one here will return true. So here, if A itself is not greater than 10, then we're going to return true. So the operator returns the inverse of the expression's result. For example, this returns false. Yeah, so this one also can be, it's like a negation aspect. Let me see if I give A 20. So 20 greater than 10, this one gives true. Then I say not. So if it's not true, okay, gives us its negation. But for this case, if 7 is greater than 5, this 7 greater than 5 gives us what? True. Then we negate it, okay? We want the opposite of the value that is returned here. So if 7 is greater than 5 is true, we want the value which is not the value returned from here, meaning false. Yeah, so that's what that code means. Then we have conditional expressions. So that has two operators that let you evaluate expressions that might otherwise require if-else statements. Okay. Yeah, so I think for operators, that's where we stopped. But then I think this slide is a bit misplaced. Yeah, slide is a bit. Let me get you some other slide.
Bring any of those devices that we can hear as we solve this. Who is connected here?
Okay. Sorry about that brief break. Yeah, so we had just finished operators. Now we're going into loops. Okay, loops in programming and in general. Yeah. So loops are basically a set of instructions that must be repeated. Okay. So in a loops context, a repetition is termed as an iteration. Okay. So if you have a block of code that you want to run multiple times, okay, so you loop. You want to perform this action multiple times. You loop. You can say, I want to play this song endlessly. So you loop through the song, play it endlessly, okay, multiple number of times. Or if you want to play the song 10 times, you can specify, I want this song to repeat 10 times. So you're looping through it. So it's an iteration. You're iterating through the song 10 times. So in programming, there comes a time where we need to loop through certain instructions. We want to run them more than once. That's why we have a concept called loops. Yeah, a set of instructions. So in that, we have what we call a for loop. So this is an implementation of a definite loop. By a definite loop, it means you must specify when it will start running and when it will stop running. Under what condition will this loop stop running? Because it's very dangerous to have a loop that you don't know when it's going to stop running, because it can make your computer run out of memory. And remember now, for the case of which have very limited memory, it is very bad to have loops that run endlessly. You have to have a condition that can terminate the running of a loop. Okay. Yes. So this is the syntax: for, then initial count value, termination condition, and then the step. Okay. So here you say where do we want the loop to start from? What condition do you want this loop to stop? Then how many steps must it run? Okay. Yeah. So that's an example of a for loop. This is a program to find a factorial of a number, let's say 5. Okay. So we start with our main program. And then we assign the value 5 to it. Then we say if this 5 here is still greater than or equals to 1, reduce its value by 1. Okay. And then basically we know that factorial is, of course, something that is found by multiplying a certain number as you reduce it. Yeah, so here we have an initial factorial variable that is declared up here. And here we say we are going to keep using this operator. So this is the operator we looked up earlier, factorial times equals to I. So this one simply means factorial is equals to factorial times I. So you're giving factorial a new value each time you're looping. So how many times are we going to loop? We are going to loop until the value of I is as long as the value of I is greater than or equals to 1. Okay. So if the value of I is now equals to 1, we no longer have to loop. So here for the for loop has 3 parts: the initializer, I is equals to now, the condition, I is greater than or equals to 1, and the final expression, I minus minus. Okay. The program calculates the factorial of the number 5 and displays the same. The for loop generates the sequence of numbers from 5 to 1. Calculate the product of the numbers in every iteration. It outputs 120. Yeah, so you can also test this code example by pasting it into that pad if you already opened that in your browser, and you'll see the output. So basically a for loop performs a certain operation multiple times, and we can see it here. But you must specify the number of times, but this is dynamic. So if I can put 10 there, it will also calculate for me the factorial of 10, any number. So this is basically a program to calculate the factorial. Yeah. And then at the end of it all, of course, we print the result. We print the factorial of that number that was given. Yeah. Then there's what we call a for in loop. So this is the beauty of that. That gives us so many ways to program. So the for in loop is a very short way to be able to loop through certain properties. Even arrays, we can loop through them, and we're going to look at those later on, I think in the subsequent lecture. So here we have the for in loop. It's used to loop through an object's properties. For variable name in object, then the statement or block to execute. So this is always a block of code that you want to be repeated. Okay. This is for the for in loop, for the variable name in the object. Looking at an example. For example, if we have an object, var object, this is a list, okay? A list of numbers, a list of integers. So the first value is 12, 13, and 14. So we say for var prop in ob, so this simply means, let's say, the property or the attribute in this object, loop through each of these properties, okay? So here the properties being 12, 13, and 14. So we loop and we print the value, okay? So this is a for in loop, okay? This is a for in loop, and this is the output. To first print 12, 13, and 14 systematically from the start to the end. Then we have what they call a while loop. This executes the instructions each time the condition specified evaluates to true. In other words, okay, the loop evaluates the condition before the block of code is executed. So this is a very smart loop also. It's not as smart as the while loop, but it's not as smart as the for loop, but then it definitely evaluates because it doesn't run before certain condition is actually true. As you can look at this diagram, okay? While condition, then the conditional code here. So here, if the condition is false, to stop. If the condition is true, perform the conditional code, yeah, until that conditional code is no longer true, then we stop. So this is a stop sign. So this is a loop. A loop means it keeps going on until certain condition is no longer true, then it stops. A clear example is also here, the same factorial program, okay? So the given code uses a while loop to calculate the factorial of the value in the variable num. Following output is displayed on successful code execution. So factorial is 120 when you look at this. So remember in the for loop, we were putting everything up here. But in the while loop, we don't have the ability to do that. So here we first say if the number is greater than or equals to 1, then we can go ahead, okay? We say, let's say the first one will be factorial, which is 1 is equals to 1 times 5. Then we reduce the value of 5 to what? By 1, which will be 4. So in the next iteration, we shall again multiply. So this one was 5. So 5 will be equals to 5 times what? 4. Okay? Like that, until the next iteration, until when this num value is no longer greater or equals to 1, meaning it's going to be equals to 0. So when 1 is equals to 0, it's no longer going to calculate the factorial. So it will exit this loop and come and print the value of the factorial, okay, here, which will be 120 because we're trying to find the factorial of 5. Then we have a do while loop. So a do while loop is one I also don't really encourage people to use so much because it's not as smart as the while loop and the for loop. Yeah, I guess, yeah, someone raised their hand. Yes, Wani. Is there someone with a question? Okay, I guess I'll continue with the illustration. So the do while loop is similar to the while loop, except that the do while loop doesn't evaluate the condition for the first time the loop executes. However, the condition is evaluated for the subsequent iterations. In other words, the code block will be executed at least once in a do while loop. So do first performs a certain action before even checking the condition. Okay, it's like when you're telling someone to please check if let's say a bottle of water is full before. We can look at this example. It's valued by 1. Okay, this is the conditional code that you want to execute. So if n is greater than or equals to 0, keep doing this. So here it will actually print 10, 9, 8. So remember, this minus minus reduces the value of a variable by 1. So 10 minus 1, 9 minus 1, 8, like that, like that. It keeps reducing it by 1 each time. So when it's now equals to 0, when it's less than 0, it will not go through this block again. So that's what a do while loop does. Then we have what they call a break statement. So sometimes when you're looping through something, you reach a point and you want to be able to control. You don't want a loop to continue working when there are certain problems. For example, let's say when you look at your programs, I know certain times when you're trying to upload certain code somewhere, then something happens. Okay, let's say you're uploading, let's say an image to WhatsApp or an image to Facebook or something, and then your internet goes off. Definitely, there are mechanisms that are there to break the operation, because you cannot upload half an image, so it breaks. Okay, remember, files are uploaded part by part. So if you want to upload a certain part of the image and then the internet goes off, we have to break. We stop there because we don't want to have an incomplete image. So also in programming, when we are doing loops, we can break. If we find certain conditions are not okay, we break off from it. Yeah, so here we can say var I equals to 1. So while I is less than or equals to 10, and then inside here we have an if statement to check. So we're going to look at if statements later on. So I percentage 5 is equals to 0. So you're saying that if I divide I by 5 and the remainder is equals to 0, I will say the first multiple of 5 between 1 and 10 is this, and we break. Otherwise, I'll keep iterating to make sure that value meets this condition. Okay, so this one here, the given code prints the first multiple of 5 for the range of numbers between 1 to 10. Yeah, so I don't really want to complicate things, but just know when you see the break keyword anywhere, it means you're stopping execution in that block. Okay, the whole loop is going to stop once certain condition is is satisfied. And for this case, they are telling you they will keep incrementing the value of I by 1 until when you divide I by 5, the remainder is going to be 0. Okay, so that is 5 basically. 5 divided by 5 is 1, remainder 0. So if the remainder is 0, we now break. So continue. The continue statement in programming is also very important. So here, it skips the subsequent statements in the current iteration and takes control back to the beginning of the loop. Unlike the break statement, the continue statement doesn't exit the loop. It terminates the current iteration and starts the subsequent iteration. So this given code displays the number of even values between 0 and 20. The loop exits the current iteration if the number is even. This is achieved using the continue statement. Okay, so here we start with var num is equals to 0, then count is equals to 0. So this is a for loop. For num equals to 0, if num is less than 20, for num less than 20, then num plus plus. So here we try to find the modulus. So if we divide the value of this number by 2 and it's equals to 0, we continue, meaning we don't do anything. Yeah, we skip it. And then here there is the increment operator. So then here we shall print and say the count of odd values between 0 and 20 is that. Okay, so remember, this code will not usually want to reach this part, so we just skip and go and start afresh. But for another value, we go and start afresh for another value. Okay, so the count of odd values between 0 and 20 is 10, which is true, by the way. You find the odd values between, if you try to manually count the odd values between 0 and 20, there are 10 of them. So this is what it does. If it finds a value that is not that is even, it skips. It doesn't count the even numbers, it only counts the odd ones. Okay, so for every odd one that comes through here, we increment our counter by 1. Yeah, so this is what the continue statement does. It helps us go to the next iteration. It doesn't execute the loop like the break statement. For it just goes to the next iteration. Okay, Yeah. So yeah, that was it about loops, and we are going to use loops a lot also. Although they also say it's not wise to use too many loops in your code, since that is where our programs start to become slow. So the art of knowing how to use loops in programming is also very important. So we have decision making. Okay, how do we make decisions in that? Okay, so control flow, a conditional or decision making construct evaluates a condition before the instructions are executed. Yes, you check. Okay, we want to know, is the email and password valid before we send it to our server? Okay, if it's valid, we send it to the server. If it's not valid, we don't send it. We tell the user that your email and password is invalid. Try to enter new emails and passwords. For example, if someone enters an email and password, an email which doesn't have, let's say, the @ symbol, and it doesn't have let's say, a domain attached to it. For example, there's no, let's say, gmail.com or restore.org, something like that at the end. Those are conditions that you try to check for. So in simple terms, control flow, you're trying to check and make sure that a certain condition is true before something is done. So conditional constructs in that include the if statement. This one consists of a Boolean expression followed by one or more statements. Then we have the if-else statement. For example, if you want to test multiple things and you don't want to use one if statement, you can use the if-else statement. Okay, this one here is majorly if let's say if this person's password is true, do this. If their password is if the password is not true, definitely it's false. This is what should be done. So it's like a fallback action. We're going to look at that also. Then there is else if. So this one you want to check multiple things. For example, in a grading system, if the grade is between, let's say, 50 and 60, what is it? If it's between 61 and 70, what is it? Between 71 and what? So this one you use else if ladders to be able to test such statements. And then there's a switch case. Switch case is so powerful also. Yeah, it is also powerful, and it's used for, it's really very important to use it at certain points. So here you just have statements that are ready to work on your value. You pass one value and then you check for multiple things that value can do. Yeah, and we're going to look at it also. So let's first look at the if statement. So if else construct evaluates a condition before a block of code is executed. For example, if, then some expression, and then these are the actions. Okay, so whatever code is inside this block are the actions to be performed if this expression is either true or false. Okay, so by the, it doesn't have to be true. You can either want it to be false before you do something, or you can either want it to be, and also want it to be true before something is performed. Okay, so that's the beauty of these if conditions. You control what do you want to be able to trigger the statements. Do you want a true condition or a false condition? Okay, yeah. So here we can look at this program if statement. The given example will print number is positive as the condition specified by the if block. Okay, so var num is equals to 5. If num is greater than 0, number is positive. So if this was -5, definitely we would not have it print number is positive. We would not even print anything for this program in particular. Then there is the if else. Okay, an if can be followed by an optional else block. The expression block will execute if the Boolean expression tested by the if block evaluates to false. So this is our syntax basically. If else, like I said, this is a fallback. If the password is wrong, what do you want to do? You want to be able to tell them that your password is wrong, try to put another one. But if the password is true, it wants to go ahead and let's say log them in and now give them access to their account. Okay, so if else, and this is how the flow goes. Condition is true, if code, this else code here. Okay, so there are two conditions. Condition true, false, then they all must end. Okay, at the end of the day, a program must have a way to end. If your program doesn't have a condition that makes it stop, then it's not really a good program. It's not safe. Yeah. So then there is a if else statement example. You can look at this example. The following example prints whether the value in a variable is even or odd. Okay. Even numbers are basically those that don't have remainders afterward, after dividing by 2. Yeah. Yeah. So the if block checks the divisibility of the value by 2 to determine the sum. So var num here is equals to 12. So if num percentage 2 is equal to 0, we print even, else we print odd. So notice how all the things we were talking about in the beginning are now coming to work for us. Okay, we're declaring a variable with the var keyword, yeah, and then we're assigning an integer to it, and then here we're using an if statement. Then here is else. Then we also have num percentage 2 is equals to 0. So this is the modulus operator, and then this one is the one that checks. It's the equality operator. You see that? This is so now this is what makes programming make sense. You pick the pieces of code and then you come and try to construct certain logic with it. So in this case, we're basically constructing logic to show us whether the number is even or odd. And then we print out the results, okay? Print out the results for this case. So then there is the else if ladder, okay? So here it's useful. This one is used to test multiple conditions. Like I told you, when you're building like a grading system and there are multiple levels that you be grading, okay? For example, if you're building a grading system for max, just max, you're saying from this to this. Then there's also for CGPA, you can say you build one for, you want to know if someone got a second class lower, second class upper, first class, or someone just got a past degree, okay? Or diploma for that case. So those are things that you can use these ladders because you're testing multiple things, okay? So if, then else if, then it must always be preceded by an else statement. So this is like a default statement to keep. So they say here, an if can have 0 or 1 else's, and it must come after any else ifs. Then an if can have 0 to many else ifs, and they must come before the else, okay? Then once an else if succeeds, none of the remaining else ifs or else's will be tested. Yes. So if one condition succeeds here, the rest will not be tested. Okay. So if the first one succeeds, we shall not proceed and test this one. And this else is always the last resort. If all these have not succeeded, we come and now check out this. Yeah. So we can look at this ladder. So still checking out num. If num is equals to 2, if num is greater than 0, definitely the number is positive. Else if num is less than 0, number is negative. Then else here, we check and say num is neither positive nor negative, okay? Yeah, so here you just guess and you know that this num being neither negative nor positive means the number is equals to 0 actually. Okay, so that is what this kind of statement tries to evaluate. So here we have seen the use of the else if. You're basically trying to check for more than one condition. And then we also have a default statement. You have a default group of statements that are going to be run if the first two statements don't evaluate to either true or false what you're checking for. Okay, so here output we say 2 is positive. Yes, 2 is greater than 0. 2 is positive. So this, we shall look at what this means in later on when we're looking at strings. This part here. Yeah. Then we have the switch case. So the switch statement evaluates an expression, matches the expression's value to a case clause, and executes the statements associated with that case. So the value of the variable expression is tested against all cases in the switch. If the variable matches one of the cases, the corresponding code block is executed. If no case expression matches the value, a variable expression, the code within the block is executed. So this one, I want to, we can again go about some rules and see. So rules that apply to a switch statement. There can be any number of case statements within a switch. So there are unlimited number that you can put there. The case statements can include only constants. Okay, so you don't have dynamic values. Dynamic values are values that change. For example, time changes, unless you want to evaluate a certain time only. Okay, so it cannot be a variable or an expression. Then the data type of the variable expression and the constant expression must match. Okay, so you can't try to compare a string to an integer or a boolean in switch cases. So Unless you put a break after each block of code, the execution flows into the next block. Okay, so if we have break statements in switch statements to make sure that the execution doesn't continue flowing. We want to stop. If we want to check to a grade of someone who has gotten a 76, okay, and then reach that block that says when someone is between 76 and this, we have already got the grade. We don't want to keep checking, so we put a block. We put a break keyword, and it must stop the execution of that what switch statement. And then here they say the case expression must be unique. Don't try to test the same thing twice. Yeah, we're going to look at a code sample to make sense. For example, here, grading. var grade is equals to b. So then we pass it here, grade. Case A, we print excellent, then we break. Case B. So this grade, if this grade is an A, it will print excellent. If it's a B, prints good. If it's a C, prints fair. If it's a D, prints poor. Else, we shall say invalid choice. Meaning if you pass a value which is neither A, B, C, nor D, it will tell you that you've entered an invalid choice, and then it breaks. So if you don't break, it keeps running. Yeah? But then when it reaches here, it can stop. But if you just leave it here and you've not broken, it keeps running until it meets the break keyword. Okay? So basically that is it. Yeah, so well, as we sum up conditional expression, these control flow expressions, we can say that that has two operators that let you evaluate expressions that might otherwise require if-else statements. So there are times where we don't want to use if-else statements, okay? Times where we don't want to make our code too long. We want to do something on one line of code. So we use such expressions. For example, we say condition, then expression 1, expression 2. So condition, I can say if A is greater than B, do expression 1. But if A is not greater than B, do expression 2. This is what it means. If condition is true, then the expression evaluates to expression 1 and return its value. Otherwise, it evaluates and returns the value of expression 2. Okay? So this is a short form of using those if statements, but it's only used for when there are only two results. Okay? We only use it for two results. And then there's this other one. If this is expression 1, then 2 question marks, expression 2. So what this means, if expression 1 is non-null, meaning if that identifier you put there actually has a value assigned to it. For example, if I say age is equals to 3, okay, this is the one we are going to take because it's not null. But if age is equals to null, then we are going to try to take this second expression. It's the one we are going to pick its result. Okay, so if expression 1 is non-null, returns its value. Otherwise, evaluate and returns the value of expression. You'll use this once in a while to make your code easy. Using too much of it also makes the code not so readable. So numbers, basically numbers in programming are exactly what they think they are. Integers and what? Floating point values. Okay. Yeah. So here the num type is inherited by the int and double types. So the .co library allows numerous operations on numeric values. So numbers, you can play with numbers in so many ways. Okay, if you look at that code sample, the files that are on GitHub, yeah, the one for numbers, you can see so many operations that you can perform. Okay, so it's very flexible and it enables us to do a lot of things on numbers, and this is what makes programming in that very flexible, and we can build very powerful applications. That's why a lot of people who are doing finance applications be going for it. Then we have what they call parsing. So sometimes, let's say someone will let's say when we're dealing with an API, you find that someone might return for you a value which is an integer as a string, meaning it's going to be between quotes. Okay, so that value is that value is a string. So you have to pass it and try to turn it into what? An integer or your double. So the parse static function allows passing a string containing a numeric literal into a number. So the following illustration demonstrates this when you look at this. And then this is the output. When you run this code, this is its output. Okay? But then if you will always get an exception if you try to pass, let's say, an alphanumeric, this one. Let's say this is a alphanumeric variables because we have 12 and A. A is not a number. So if we try to pass this, we are going to definitely have issues. Okay? So which is a format exception. Okay? You pass letters into this function, then you have a format exception. Okay. Yeah. So we have number properties. Numbers have properties. If you look at the code example, it will show you exactly how these properties are. Yeah. So if you want to check the hash code of a number, which are the 16-bit values of the numbers, you can just use those code samples also. Let me just browse through them real quick. Okay. So we are on numbers. So these are some of the implementations if you were to look at it. For example, hash code int n is equals to 5,000, then you print its hash code. Then if you want to know that if a value is finite, okay, finite number, if the number is not a non or positive infinity or negative infinity. Finite number is a number that is basically fixed. So it's not finite, it's not growing or decreasing. Then infinite, this one still, to tell you whether the number is infinite or not. So these are all properties that we can see in this simple chart here. Okay. Then we have is negative. If the number is negative, otherwise false. Sign. This one returns the sign -1, 0, plus, depending on the sign and numerical value of the number. Okay. Then is even. Is the number even? Is it an even number? Remember the other side you are writing code to check for an even number. But then here they are telling you that you can be able to use this property is even to be able to know if a number is what? Even. Then is odd. This one tells us if the number is an odd number. So these are what? Properties. So they help us, they are inbuilt things in that, and they help simplify our life. Instead of us writing code to check these things manually, that comes up with this to simplify our lives. So yesterday I also mentioned that comes with a lot of libraries. So these are batteries. Batteries that save us from writing excessive code. Yeah. Then we have number methods, ABS. This returns the absolute value of the number. So by absolute, what do I mean? If a number is, let's say, -4, its absolute value is just 4. We don't care about the negative or the positive, we just give you the 4. Then seal. If a number is, let's say, 4.3, okay? We want to seal, we return the least integer, no smaller than the number. So that is going to be 4. Okay? Then compare to, this compares one number to another. Okay? So these operations are all here in the numbers thing. Is even, okay? As you can see, what I was saying is odd. Then the number methods, abs, returns an integer representing the absolute value of the number. Yeah, so all these code samples are here, and you can always run them to see for yourself and try to change the values of the variables. Don't leave them as they are here. Try to change. Even if you get an error, it won't really crash your computer because, yeah, it can't really crash your computer. Compare to. So for here, where they say it returns the value 0 if the values are equal, the current number object is greater than the specified numeric value, then -1 here if the current number object is less than the specified numeric value. So let's say A is 2.4. A dot compare to 12. Okay? A dot compare to 2.4. A dot compare to 0. So here you'll already see the result. Are they equal? If they are equal, returns 0. If the number you're comparing to is greater than the specified numeric value, then it gives you a 1. If it's less than, then we give a -1. Okay, that's how these values are evaluated. Then flow. So the flow method, as we mentioned here, flow does the opposite of ceil. Okay. So flow returns the greatest integer not greater than the current number. Returns the greatest integer not greater than the current number. Then remainder. Remainder returns the truncated remainder after dividing the two numbers. Let's look at that code also. Okay. When you look at this, A dot remainder of 2, then B dot remainder 2. Okay. Yeah. So when you divide 10 by 2, what is the remainder? It's 0. When you divide B 17 by 2, the remainder is 1. So that's what it will return for us, the truncated remainder. Yeah. Then we have this one of round, which returns the integer closest to the current numbers. Yeah. Only the integers. And then we have to double. This one converts, let's say if you have an integer and you want to convert it to a double. So it converts the value to a double. Then to int, this returns the integer equivalent of the number. For example, after passing a certain value, let's say you get a value that is a string, let's say it's 12, and you want to pass it into a number type. Later on, you want to make it specifically an integer, let's say from a double to an integer. So you use such a value, you use this helper method. Okay. Then to string, if you want to convert an integer to a string or any number to a string, you use the toString. Okay. So we can look at that. So that toString is very useful in most cases. For example, if you want to display a number in a text widget in Flutter later on, you must always convert it to string before you can display it. So let me show you that. So the toString method, this toString, okay? So here we first have an integer that is 1, and then now we want to convert it to string. So we say int n1 is equals to 2. So var value is equal to n1 dot toString. So we're converting this n1, which is currently an integer, to a string, and then we print. So here we use this other keyword that we were checking earlier on. That's earlier on we tried to check it using an integer. We were saying if let's say n is equals to, if n, yeah, we were saying n is int, and it was telling us either true or false. So here we say value is string to check whether this integer has actually been converted to a string. So this will definitely tell us true. Okay. Yeah, then truncate returns an integer after discarding any fractional digits. So this is just used to remove fractional digits from an integer. For example, if a value was a double, we shall only pick the whole number, and then we drop all the other fractional parts of it. Okay, so that's what the truncate method does. So all the examples of those methods are in the code sample given. So string. Yeah, so string is the second last thing today. So strings and integers work hand in hand, really. So we really need strings. They're very important. The text we see appearing in our Flutter apps, those are strings usually. Yeah, because you must always convert an integer to a string before you can display it. Yeah. So the string data type represents a sequence of characters. So that string is a sequence of UTF 16 code units. Okay. So these are basically standards that have been agreed upon by some engineering societies. For example, if we look at IEEE, there are guys who set some standards, and then programmers have to be able to implement them in their programming languages. Okay, so they do this because at the end of the day, the machines people are going to be using are universal. So we don't want to be able to use different. We don't want to be divided by the architectures that different devices use. So they come up with standards that every programming language has to follow. so that the hardware devices can be able to execute certain code. So string values in that can be represented using either single or double triple quotes. Single line strings are represented using single or double quotes. So let me explain this with an actual example, not even the syntax, an actual example. So if you look at string one, the variable string one, it's a single line string. So although you may see it here like this word string here as going to the next line, in your actual code you can't do that. You have to make it you have to put it in a single line. Okay, even this one, string 2, single line. Okay, but then if you have something long, let's say if you're building, let's say, a screen for privacy policy or terms and conditions, and you want to store that text, instead of having a web page and then you display the web page in your Flutter app, you want to store that text in a variable. Usually use a multi-line string. So when you use a multi-line string, you can be able to format, you can be able to look at your code really nicely, and then also format it nicely. It makes it readable. So if your string is too long, you use a multi-line string so that you can be able to look at your code really nicely, and it's formatted very cleanly. Okay, so there are two ways of using a multi-line string. So there are these ones for the single quotes. You put 3 of them. Then for the double quotes, also 3 of them. 3 starting and 3 ending. So this also prints the output of these ones. So it's a single line string, single line, multi-line, multi-line, okay? So basically this is how you create strings with the string keyword. But you can also create it using the var keyword. But then what matters is what value do you give it? How do we know that it's multi-line or single line? So this is the magic, okay? These quotation marks, okay? So if you use triple quotation marks, triple double quotation marks, or triple single quotation marks, you'll be able to have a multi-line string, okay? Yeah, so string interpolation. This is something I almost mentioned to you in the previous section when we were looking at certain numbers, when we were printing certain numbers, okay? So string interpolation simply means combining 2 strings, okay? Combining 2 strings, okay? Yeah, for example, if you've used the banking apps, I can show you where string interpolation is very important, okay? For example, if you're checking for your balance using a banking app, when they tell you your balance is this, so the statement your balance is static, it is hard-coded, but then the value that they show in front there, the currency and the actual value, the figures, those are dynamically generated from, let's say, an API. They come from an API or a database or something. So you concatenate the statement your balance is, and then those values. So that's an example of string interpolation. You're trying to combine 2 strings to give meaning to a user, or to the output that you're trying to generate. Okay, so that is also very important. So if you look at this, we are trying to concatenate hello and world, those 2 words. So in that, we can just add, we can use the plus sign, okay? Hello, world. So this example is really powerful, because on top of using the plus sign to combine string 1 and string 2 and assign it to the res variable, we are also using this helper, the $sign, then you open these brackets, you open these angle brackets, okay? Then you put your res keyword. So this is concatenation also. So here we concatenate, and here we also concatenate, okay? So here we're concatenated the variable hello and world. Then here we're concatenating the statement, the concatenated string, then the value of the result, okay? So this is what it produces as the output here, hello world. Remember, there is no spacing here. If we ever wanted to space hello and world, we can concatenate an empty string here, or empty quotation marks with a space, and then we would have a space between hello and world. Sure. So string concatenation basically means you're trying to combine 2 strings, and we do it a lot in programming. We're going to be able to see it. So, like I said, this helper you're seeing here, this construct you're seeing here, can be used to interpolate the value of that expression within strings. And currently, in the new versions of that, this is being encouraged more than the plus sign. Okay. So when you use a plus sign, you usually find your code editor telling you, why don't you use this other one? So this is one that I always encourage us to use, okay? Because it looks cleaner. It looks cleaner. It doesn't make it look like math, yeah? So if you look at this example, int n is equals to 1 plus 1. So that is math. You're adding 1 and 1. Then string 1 is equals the sum of 1 and 1 is this. Print string 1. Then string 2, the sum of 2 and 2 is. So here we can even perform math operations, okay? We can add 2 and 2. Inside this interpolator, yeah, we can add 2 and 2 here. Okay, so it's really powerful when it comes to when it comes to concatenation. Yeah, we can perform math operations with it. So this is how this is how I can justify the statement I made about your account balance being about them telling you that your balance is, or your account balance is, then they concatenate. Okay, so they actually show you the integer value or the double values. Yeah, so that is it about concatenation. Then string properties. Strings also have properties that help you. Then it's empty. You want to know if the string has some data or it has no data. Then the length. How many characters are in that string? Okay. For example, one with the words hello space world, you can actually know the number of characters in that string using this method, the helper method property. Length. Okay. Remember, a space in a variable is also counted as a character. A space is counted as a character. So just know, programming, you have to be very specific with what you're doing.
Yes,
okay, because everything consumes memory, so it is counted. Then we have string manipulation. You want to convert a string from, let's say, lowercase to uppercase. So lowercase is basically small letters, uppercase letters, big letters, okay, capital letters, okay. Then trimming. If there is space between the, let's say if your string starts with a space, then the word, then again a space at the end. This trim method removes those leading and trailing spaces. So that is called white space. White space doesn't really cause errors in programming. Doesn't really cause errors, at least not in that. Maybe in Python programming language, you can have issues with white space, but in that we don't have. So the trim method removes any empty space between words that are in a variable. Yeah. Then compares this object to another. This one compares a string to another string. So if the strings have the same values, let's say hello and hello, then definitely the Boolean result is true or false. Then replace all. Let me open this file for strings, so you can follow along with the one for strings also. Yeah, you can see that here we're saying the string data type represents a sequence of characters. We talked about this, then we showed the example. Yeah, so all the code is there and you can run it always. So then we reach the interpolation part, then we looked at the properties, okay, and now we are looking at methods that are used to manipulate. Say lowercase string.lowercase, then this is the sample syntax. If you want to capital A, B, C, and we try to change it to lowercase, a string that's already in lowercase remains in lowercase even if you apply the variable to it, the value to it. Then the ones of uppercase, the one that is in uppercase remains in uppercase, then the one in lowercase changes to uppercase. Yeah, so these are some of the string methods. And then trim, like I said, it removes space. For example, using this variable hello has a lot of space before the word itself that is there. So the trim method helps remove this extra space. It actually saves memory, because then all this is catered for, all this occupies memory, and yet there is no value there. Okay, and then this one is worse. This one has space before and after, but when you trim, it removes that space. Okay, yeah, so that's the importance of some of these helper methods. Then compare to, we talked about it comparing. Okay, you're comparing, let's say, string 1 to string 2, string 2 to this. Okay, so you have to also be careful about the return type, the integers. So when strings are equal, it returns what? 0. So when the first string is greater than the second, returns 1, and when the first string is smaller than the second, returns -1. By greater than, they look at the alphabet. Okay, So here, essentially, B is always greater than what? A. Why? Because A comes first, B comes second. So B is greater than A. Same cases with C. C is greater than both B and A. Okay, so that is what they mean here by comparing and returning those results. Then replace all. So this is something that is also very important, and usually we use it a lot. Let's say if you have a string hello world and you want to replace the word world with all. Okay, so here you use this string one dot replace all. Okay, but you have to, this one is very case sensitive. So if the word world in this string starts with a small letter, and then here for you specify a capital letter, it will not replace, it will not find it. Okay, it will not find that word. Yeah, then we have the split method. So split helps split a string. For example, for this string here where we say today, comma, space is, comma, space Tuesday. So we say new string, string one dot split. So splitting, we are going to split every word that occurs before a comma. Okay? So when you find the first one, we shall split today is one word of its own, is, then Tuesday. So this one returns a list. So let me demonstrate this one also. This is something I should demonstrate. Okay, remove my comments. So whatever these slashes you're seeing are called comments. Okay, they are called comments. So comments prevent the code from being executed, and sometimes we use it to just explain what our code is doing. Okay, so this is the result of this split method. We are splitting the string whenever we find a comma. So it returns a list of the words that were picked from the string itself. So here it has returned today, comma, is, and Tuesday. So you notice these brackets. This means that it's a what? It's a list. Okay, these square brackets are there to mean a list. A list is like an array. Okay, can store a variable, the same data type, multiple variables of the same data type.
He's crying.
Okay. Yeah. So we looked at that. The substring to string. So to string, let's say if you have an integer and you want to convert it to a string, you use the toString method. Then this one returns the code unit at, returns the 16-bit UTF-16 code unit at the given index. Yeah, so that is also if you want to know the details of that value. Then we have Boolean. So Boolean is the easiest in that programming because we have two values. It's either true or false. Okay, so that provides an inbuilt support for the Boolean data type. The Boolean data type in that supports only two values, true and false. So the keyword bool is used to represent a Boolean literal in that. So the syntax for declaring a Boolean variable in that is as given below. Bool varname equals to true, or bool varname is equals to false. Okay, so it's either true or false. There is no in between. So that's what Booleans mean. But this code example here, we are assigning a value of a Boolean expression using this comparison operator. So we're saying if 12 is greater than what? 5, it will what? It will assign that value to test. So here, test will definitely be true because 12 is greater than 5. But if we wanted it to be false, we would say 12 is less than 5. That one will be false. Okay. So that's basically how Booleans work. So yeah, up to this point, that is what we had for today. There are a lot of concepts. That's why I decided to first clear these ones so that we can be able to look at them. Yeah. So more code examples are going to come for the subsequent things we're going to look at in that programming. Yeah, so I guess tomorrow we shall be able to look at what they call lists, maps, and list maps. Then we shall look at certain examples of, let's say, classes and objects also. So after we look at those, then we can be sure that we can attack the flatter side of things comfortably, because basically this is going to be majorly what we're going to be using for programming. So there's nothing new you're going to see in Flutter that you haven't seen here. You're going to see numbers, you're going to see booleans, you're going to see strings, you're going to see operators and all that. So for today, I guess this is it. Thank you very much for tuning in. Maybe we can have a word from some people. If you have questions, you can also ask some questions. Yes, Mr. Ali.
Yeah, thank you so much. Good evening, everyone. I first of all apologize. I joined late. Though I missed some part of this presentation. My concern is only about the Flutter. I don't know if you have already recapped on it from the beginning. I managed to download the Flutter yesterday, but from there I wasn't able to navigate some parts. Yeah.
Okay.
So, yes.
Are you using Windows?
Yes.
If you're using Windows, we could go through it and we see how to fix it on your computer. Yeah. So you can choose a certain hour. Let's say if you could be available tomorrow morning hours, it would be perfect for us to be able to fix that. I don't know if you can be available.
Tomorrow, like at what time?
Tomorrow essentially from around 8 to 10.
Okay, let's try to see at around 8.
Okay, that will be perfect. I will show you. See how to fix that error there. We'll see how to fix the installation. But as of now, I hope everyone can be able to access that pad and try to run the code, because really, it's very important to have these fundamentals of that programming. And trust me, there is more content out there about that programming. It is enormous. There is enormous content, but what matters is, do you understand the basic concepts? Do you understand how to construct a basic loop, a for loop, a while loop? Do you know how to use if statements? Do you know how to use variables to store certain data? Yeah, so that is what really matters. That's why we're trying to go into this. So tomorrow's instructions will be able to help us deal with things we're going to meet in Flutter. Okay, when we look at lists, we look at maps, we are going to use a lot of that in Flutter. So tomorrow is going to be a very important day, and I encourage everyone to be there. Even those who are not there right now, you can always tell them that tomorrow is going to be a very important session, because we're going to look at classes. Okay, so if you look at Flutter is full of classes. Okay, that is object-oriented programming. Okay, we shall also talk at what object-oriented programming is. So all those concepts tomorrow that are going to really push us to Flutter. Okay, yeah. So tomorrow is going to be a very important day. So otherwise, thank you all for tuning in. I am glad today I didn't spend too much of your time. Yeah, I hope that my timekeeping will always be good. And also, if I'm always taking too much time, you can remind me, because I know people have multiple things to do. So thank you very much for tuning in today. And if anyone has any more questions, you can ask me before we break off and we call it a night. Okay, I guess no one has a question. So thank you very much for tuning in. The resources for today's facilitation are in the WhatsApp group, and you can always access that GitHub repo of mine and be able to read what is there. Even tomorrow's code will be added to the same thing, to the same link, so you don't have to. There's no new link going to be shared. It's going to be the same link. You'll just find, let's say, new numbers to represent the new things, like the concepts I'm going to be talking about tomorrow. And then, yeah, we're going to proceed that way. So when we reach Flutter, we shall also share a new link for only Flutter. So thank you very much for tuning in today, and have a good night.
Thank you.